Hi, welcome back. In our previous lesson, we started with some practice questions on equivalent and compensating variation. Today, we'll be moving on to part 2, where we focus on equivalent variation. To recap, we saw a consumer named Peter who had a utility function represented as x raised to the power 0.5, y raised to the power 0.5. Now, Peter was faced with initial prices of good X being equal to 1 and good Y being equal to 1. Now, assume that the price of good X increases from Px equal to 1 to Px prime being equal to 2. We calculated a compensating variation as the income that we need to compensate Peter to keep Peter on his initial level of utility despite the change in price. Today, we'll be moving on to calculating the equivalent variation of this change in price. Unlike the case of compensating variation, if Peter were more interested in keeping relative prices unchanged, or in simple terms, to avoid the price change altogether, as compared to keeping his utility constant, then this will be equivalent variation. So in this case, equivalent variation will be the change in income or utility that Peter would have to give up to keep relative prices constant. To compute equivalent variation, we need to keep Peter at the old prices but with a new level of utility. So when we were calculating the compensating variation, the aim was to keep Peter on old utility but with the change in the price. Now we're going to move to the flip side. Keep Peter on the old prices but with new utility level. So we know that when the price of good X increased from 1 to 2, Peter's utility decreased from U1 being equal to 4 to U2 being equal to 2.828. Now we can rewrite Peter's utility function as U being equal to M divided by 2px raised to the power 0.5 and then M divided by 2py raised to the power 0.5. We were given these two demand functions in our question. So our aim here is to keep Peter on initial level of prices for both good Y and good X. But to do this, Peter is willing to sacrifice some level of utility. And so Peter is willing to move from U1 being equal to 4 to U2 being equal to 2.828. To calculate equivalent variation, we want to keep Peter on U2 but with initial level of prices. So what is the income that Peter will have to give up to achieve this? So we are going to represent the new income that Peter needs as M prime prime. Let's substitute in the prices. So we have the new utility as 2.828 being equal to a new level of income divided by 2 multiplied by the price of good X, which is 1, raised to the power 0.5. And then we have a similar case for Y. All that this function is telling us is, despite the change in price of good X from 1 to 2, Peter does not want to experience this change in price. What he is willing to do is to sacrifice income, which indirectly means that he's sacrificing his level of utility. So the idea of equivalent variation means that Peter is willing to give up some level of income, which means that giving up some level of utility to keep prices of good X and good Y constant. So if we solve this out, we are going to arrive at 2.828 being equal to M prime prime raised to the power 0.5 plus 0.5 divided by 2 raised to the power 0.5 multiplied by 2 raised to the power 0.5. This is going to give us M double prime being equal to 5.6569. The equivalent variation is therefore the difference between this new income and the old income. So we know our new income is equal to 5.6 and our old income was equal to 8. So the equivalent variation, the difference between M and M double prime. Now M, which is the old income, is 8 and M double prime, which is the new income, is 5.6569. 69. Equivalent variation in this case is 4.686. This is the amount of money that Peter is willing to sacrifice. Keep relative prices constant. To see this on the graph, we know that before the change in price, Peter will be on equilibrium level E1 on budget line B1. Now, typically, an increase in the price of good X will move Peter to a new equilibrium point E2 on indifference curve U2 and then budget line B2. So what we have done here is we want to keep relative prices constant. So to do this, we're just going to draw a new budget line parallel to B1 and tangential to indifference curve U2. So this brings us to a new budget line PE. M being equal to 8 is the old income, and then M double prime being equal to 5.66 is the new income that Peter needs to keep relative prices the same, but sacrificing utility, therefore moving from indifference curve U1 to indifference curve U2. So the difference between this is what we have calculated as our equivalent variation. This is all that we have on our practice questions on compensating and equivalent variation. Our next lesson will be on life cycle model, focusing on intertemporal budget constraint. If you enjoyed today's lesson, consider subscribing. Thank you.